When we look into the night sky, we aren't just seeing stars. We're looking back in time, billions of years into the past, toward one of the greatest mysteries of all: what happened before the Big Bang. The Big Bang, which occurred 13.8 billion years ago, was not an explosion in space. It was the birth of space and time itself. Imagine the entire universe compressed into a tiny, unimaginably dense point. Then, in an instant, it expanded, forming the hot, dense fireball that eventually cooled to create atoms, stars, galaxies, and everything we see today, including ourselves. But the question that has puzzled scientists for decades is whether that was truly the beginning, or if there was something before it. Physicists believe that before the Big Bang, the universe experienced a phase called cosmic inflation. During this brief instant, the universe expanded exponentially, far faster than the speed of light. Imagine something smaller than an atom suddenly growing large enough to encompass the entire observable universe, which today contains hundreds of billions of galaxies. When this rapid expansion ended, the energy driving it transformed into particles and radiation, forming the building blocks of matter: protons, neutrons, and electrons, which later combined to create atoms and, eventually, stars and galaxies. Some theories suggest that inflation might not have stopped everywhere at once. In other regions, new universes could be forming continuously, potentially creating an infinite multiverse. In that scenario, our universe might be just one bubble in a vast cosmic foam, the one with the right conditions to support life. Some models propose that our universe exists on a higher dimensional brane, a sheet floating in space with more dimensions than we can perceive. The Big Bang might have been caused by a collision between two such branes, releasing immense energy and giving rise to the hot, dense state we identify as the beginning of our universe. While this idea may sound speculative, it is grounded in advanced mathematical frameworks and could one day be tested. Evidence from the cosmic microwave background, the faint afterglow of the Big Bang, released about 380,000 years after it, occurred gives scientists clues about the structure and early behavior of the universe. These measurements act almost like a baby picture of the cosmos, showing us the earliest patterns and irregularities in space. To understand what happened before the Big Bang, we would need a complete theory of quantum gravity, uniting Einstein's general relativity, which describes the cosmos on large scales, with quantum mechanics, which governs the microscopic world. Our current theories break down at the earliest moments of the universe, a period known as the Planck epoch. In this extreme environment, even space and time behaved differently, and cause and effect may not have applied in ways we understand. So far, physics has found no confirmed instance of something arising from nothing. The universe's ultimate origins remain beyond the reach of our current knowledge. Some cosmologists have suggested that the universe could be cyclical. Over vast timescales, it expands, cools, and empties, eventually reaching a state that might give rise to a new universe. In such models, the very hot, dense state of our Big Bang could correspond mathematically to the extremely cold, empty universe of the distant future. This does not imply a cause in the usual sense, because time itself behaves differently in these conditions. But it offers a possible explanation for how the universe might rebirth itself. Other interpretations of quantum mechanics, like the many worlds theory, suggest that every possible quantum outcome occurs in a separate universe. If we combine this idea with the notion of a cyclical universe, our Big Bang could be the rebirth of one quantum multiverse, containing countless universes, each with its own set of possibilities. Some researchers even hope that traces of previous universes might exist in the cosmic microwave background, providing subtle hints about what preceded our universe. Observations indicate that the universe is expanding at an accelerating rate. Stars will eventually burn out, galaxies will drift apart, black holes will evaporate, and the cosmos may enter a dark, empty state. Yet even in such a distant future, some theories suggest that the conditions could arise for a new cycle to begin, perhaps leading to another Big Bang. Life, stars, and galaxies may fade, but the universe itself continues in ways that are still mysterious and awe-inspiring. Ultimately, we still do not know what, if anything, existed before the Big Bang. It could have been another universe, a multiverse, or conditions that are beyond our current understanding. The search for answers pushes the limits of science and philosophy, forcing us to question the nature of space, time, and reality itself. Every star, galaxy, and particle is part of a story that began long before we existed, and the universe continues to evolve in ways that may remain beyond our comprehension.